Hi, to write a solution for random quicksort, the first thing we do is understand what's the difference between the normal quicksort and the random quicksort. The only difference between them is actually how we decide what is our pivot value. So in a normal quicksort, you can use the first element as our pivot value. That's the simplest case. Or we use the last element. Or in our case, in previous tutorials, we use the middle point by having left plus right anchor and divide them by 2, get the mass flow value, such about the reminder. So in this case, it's going to be we have 10 an array of sets 10, right? So 0 plus 9, 0 plus 9, and is the left anchor and right anchor, and divide them by 2. And avoid the, ignore the reminder, we get 4. So position 4 is our pivot value. And we are going to do this recursively every time we pass in new left anchor and right anchor, right? So the random quicksort will take in the left anchor and right anchor and pick random element that are within the two and include the left anchor and right anchor themselves. So that's the only difference. So without further ado, let's write our solution. So function called random quick sort and passing input array, and first thing we do is to check the length of the array, make sure it's at least have 2 elements, otherwise we return the input array. Then we can write our left based on the left anchor value, or if it returns undefined, we just initialize with 0. So it's a recursive method, so let's pass in the left anchor and right anchor as well. So then we can do the same for the right index. So it's going to be right anchor. If it returns undefined, then we use the input array dot last and get the position of the last element. Then we can declare a breakpoint and passing a function that's going to return our breakpoint. We will name this function random sort left and right, and it's going to take in the input array reference and pass in the left and the right index. So let's write our random sort left and right function, and it's going to take in the left and the right. So here is the place that the difference. Here's the difference. So we is going to declare constant random pivot index. Yeah, that's the right name, pivot index. And we passing the random index. So let's calculate what the random index would be. So we want to get left to right. So let's say in this case our left is equals to 4 and the right is equals to 6. Our result random pivot index should be either 4 or 5 or 6. So the algorithm should look like left plus 2 values. So we can use mass.random, and okay, it's going to return us a value that's between 0 to 0.9999999. And how do we use this to get our function? So, and if we divide right by left, we can get a value of 2. Okay, so left is 4 plus mass.floor, that's going to get the closest integer, and we pass in the mass dot random 0 to 0.99, and it should times 3, and then we can get so this equals to 4, and this is going to return us with 0 or 1 or 2. Okay, so the result would be 0 or 5 or 6. And number 3 will be can be obtained from right divided minus left, and we need to pass it by 1. Okay, I think this will do. So let's rewrite the function and passing the algorithm that we generated from here. Okay, so let's revise. This is going to output the random pivot index in the input array. Then we can use our declare pivot value at last and passing the input array at the index of random pivot value, and then we got our pivot value. Okay, so then we can start looping and swapping. So as long as left anchor is haven't crossed the right anchor, right? We do first find the left anchor index. So as long as input array at index of left is still smaller than the pivot value, we move on. And as long as input array at the index of right is still bigger than the pivot value, we move on. We move on from right to left, so right minus minus, and by the end of it, after we find the left and right index anchor position, and we check again. So if left is still not crossed right, we do the swap. So let temp equals to one of the values that's stored in the anchor, and update the value and update the other value. Okay, after this is done, we move on the left anchor and right anchor. Thus, by the end of this while loop, our array will be sorted into left bigger and equals to pivot value, and right smaller. Left hand side smaller or equals to pivot value, and right hand side bigger or equals to pivot value, right? So you can then return our pivot, the breakpoint, using the left position. Okay, so the breakpoint is decided here, returned. Then we can check, is there still elements on the left that are from the position breakpoint -1? If yes, we do the sorting again. So random quicksort function, the initial function, we call it recursively, and passing the input array, passing the new left anchor, passing the new right anchor. So breakpoint -1, yes. Then we do the right. So it's right bigger than the breakpoint, still means still elements on the right hand side of our breakpoint. If yes, then random quicksort, passing the input array, passing the new left anchor, that's going to be our breakpoint, and passing our right anchor. Okay, so by the end of these two if statement, our array will finally be sorted, so we can return our input array here. Let's test our solution by console.log. Invoke the method called random quicksort, passing the unsorted array. It's copy. So let's call our file with node quicksort. As you can see here, our array is sorted. So this function is also going to work on negative values and float. It shouldn't be a problem. As you can see, our array is sorted. So this is typically how we can write a random quicksort with JavaScript. Thank you for watching.